Okay, so we're doing our midterm exam review for Unit B. This is the key, and actually this looks a little bit different because I made a typo on the on your packet. So it was originally not factorable, but we are factoring here. So we need two factors of 45 that combine to get 18, and that's going to be 15 and 3 because really, this should be a plus. All sorts of problems with this problem. So two factors of positive 45, negative 15 times negative 3 is positive 45. If I add them together, I get a negative 18. So something to think about. Now for number 2, this is where we need to use one of our methods. So we can look and say, well, 4 times 28 is 112. So if we want to, we can use the box method for this. And so the box method, we just make a nice little box here. And we cut it into 4 corners. And in the first box, you put the first term, so 4x squared. In the last box, you put the last term. And in these other 2 boxes, we need 2 factors of 112 that combine to get 23. Yet again, 112 is from 4 times 28. So if we just go down the list, we could say, all right, well, 1 times 112, 2 times 56, 3 times, I don't believe anything. 112 is divisible by 4. It's 4 times 28. 5 and nothing. 112 divided by 6. Nothing. 112 divided by 7 is 16. So there we go. We can see that that combines to get 23. So this is going to be a 7x and a 16x. Now in each row and each column, I'm going to factor out the greatest common factor. So this first row is going to be an x. Second row, 16 and 28 both have a common factor of 4. And in the columns, I get 4x and 7. So this leaves me with 4x plus 7 times x plus 4. And of course, I should check this by multiplying my answer out. And if I multiply this out, I will in fact get 4x squared plus 23x plus 28. Now for a problem like this, for number 3, this is actually just a nice little pattern here. This is, we could factor this or realize this is a difference of 2 squares. The square root of 9x squared is 3x. The square root of 36 is 6. So I can do that. Now, I should factor this further because I could factor out a 3 from this. So that's 3 times x minus 2. And this is a 3 times x plus 2. So that's actually going to give me a 9 times x minus 2 times x plus 2. Interestingly enough, if you originally factor out a 9, you get x squared minus 4. So you still get 9 times x minus 2 times x plus 2. This right here is a perfect square trinomial. So because it's a squared plus 2ab plus b squared, where a is equal to 3, b is equal to 2, and so 2ab would be 3 times 2 times 2, which is 12. So this factors into a plus b squared. So this is just going to be 3x plus 4 squared. You could use any of the methods to factor this as well. There's nothing wrong with that. But by realizing that this is a perfect square trinomial, it saves you so much of that precious, precious time. Now to solve these equations, we need to factor. So whenever you see a quadratic polynomial here, you need to factor in order to solve. We can't subtract. So we need two factors of 42 that combine to get a negative 13. Well, that's just going to be a negative 6 and a negative 7. So we set each of these factors equal to 0. And so we get x is equal to 6, and x is equal to 7. So we get 6, 0, and 7, 0. Those are the two x-intercepts, the two solutions for this. Now for this one, again, you can use any of your methods, but this is nice because 3x squared is, well, 3 is prime, so the only two factors are going to be 3x and x. The only two factors, well, there could be other factors of 4. So we need to think about what we can multiply here. And if we do 2 and 2, notice we have 6x and 2x. So if I do a positive 2 here, I get positive 6x minus 2x will give me a positive 4x. So then I can set these two factors equal to 0. And I get x is equal to 2/3 and x is equal to negative 2. So I get the answers 2/3, comma 0 and negative 2, comma 0. We don't want to leave our answer as x equals x equals. We could put a comma between these, but leaving it as x equals something implies that it is a line. We do not want a line, we want points. All right, we want to write this in vertex form. Well, vertex form is y is equal to a times x minus h squared plus k. So what we're going to need to do here, if you realize this is a binomial squared, we need to make this a perfect square trinomial. So the first step is to factor out a from the first two terms. So I factor out the 4 from these first two terms, and I ignore that 3. Now, inside these parentheses, I'm going to make this a perfect square trinomial. So I need to take this, divide it by 2, and square it. So I take this middle term, divide it by 2 to get negative 4, and square it to get 16. So now, f of x is equal to 4 times, I can factor this to be x minus 4 squared. Notice it's actually just this value, plus 3. So from this, I can see my vertex is at 4, 3, hk. So make sure you know this is called completing the square. I don't really care how you find the vertex. You could find it a bunch of different ways. But this, I think, is the most straightforward approach. So definitely review that. Division. We are just going to be using synthetic division. That's the only type of division we went over. So here, if x minus 7 is our factor, the 0 is positive 7. And so the coefficients are going to be 1, negative 4, negative 25, and 28. So all we have to do is bring this down. So we get 1. We multiply to get 7, 3, 21, negative 4, negative 28. This right here is our remainder. These are all going to be coefficients for the quotient. So we always subtract 1 degree. So if we start it with x to the third, we have 1x squared plus 3x minus 4. And so that is our solution. With this next one, we're going to have a negative 1, because if the factor is x plus 1, the 0 is negative 1. And we have 1x to the fourth, 0x to the third, 0x squared, 0x minus 1. These are fillers. Don't forget that this is x to the fourth plus 0x to the third plus 0x squared plus 0x minus 1. we need to have all of the coefficients for all the degrees. So we bring this down, so we get 1, negative 1. Here we add to get negative 1. We multiply to get 1. We add to get 1. We multiply to get negative 1. We add to get negative 1. We multiply to get 1. We get 0. So keeping with our degrees, one less, we get x to the third minus x squared plus x minus 1. And we could factor this further, but they're just asking us to divide. So we can leave it like this and not have to worry about factoring this further, although I am really tempted to do that. All right, complex numbers. Complex number follows the form a plus bi. So don't forget that we are going to just combine our like terms. So we have negative 3i plus 2i plus 6 plus 4. So we get negative I plus 10. Watch the sign between the parentheses because here we're just adding. I think on that test we took, a lot of people tried to multiply. Now here's where we multiply, and we treat the y just as we would any variable. So we get 27 minus 9i plus 15, whoops, that's 27 minus 9i plus 6 times 9. 6 times 9 is 54i. And then minus 18i squared. So we get 27 plus 45i minus 18 times I squared, but I squared, don't forget, is negative 1. So we get 27 plus 45i plus 18. We can combine our like terms, so we get 45i plus 45. Hey, look at that. And this just goes back to that a plus bi form that we write for complex numbers. All right, next up, we're graphing. So we have this whole cluster, and we want to find the x-intercepts. The x-intercept is where y is 0. So we want to make y 0. Well, when y is 0, we can factor this. Actually, these all have a common factor of 4x. So we factor out of 4x, and we're left with x squared plus 5x plus 6, which leads to 4x times x plus 6. Oh, no, not x plus 6. You can sense the moment of panic. X plus 2 plus x, or times x plus 3. These are the correct factors, so these are going to give us x-intercepts of 0, 0, negative 2, 0, and negative 3, 0, because all I have to do is set those factors equal to 0 and solve. Now the y-intercept is where x is 0, but if I make x 0 here, I get 0 plus 0 plus 0, so I get a y-intercept of 0. Now I just need my end behavior. So because the degree is odd and the leading coefficient is positive, I get that as I go to infinity on the right, y goes to infinity, and as x goes to negative infinity, y goes to negative infinity. So I give it some little bumps here, and leave it like that. I don't have to worry about what my relative maximum, relative minimum are here. That's not an important piece for right now. So we just got to know that end behavior and how to find our intercepts. And here, so we want to find a whole bunch, including the whole. So the x, well, let's find the whole first. So what we need to do is we need to factor this completely. Both numerator and denominator are factored. Any common factors between the numerator and denominator are going to be wholes. So since there are no common factors here, nothing I can reduce, there are no wholes. Anything that makes the numerator 0 that remains after factoring is going to be an x-intercept. So actually, I'm going to have an x-intercept at 0, 0. Anything that makes the denominator 0 that isn't factored out is going to be a vertical asymptote, so x equals 4. The y-intercept is when x is equal to 0, so I get 0 over negative 4, which is 0, 0. But of course, I already got that for my x-intercept. And the horizontal asymptote, remember we have 3 rules, so we have to look at the degree in the numerator and denominator. Here they're the same, so the horizontal asymptote is going to be y is equal to the leading coefficients divided by each other. So 7 divided by 1, so y equals 7. For this one, there's actually a little bit of factoring that we can do. So we get x plus 9 divided by x plus 9 times x minus 9. Notice the x plus 9's cancel out, so we get 1 over x minus 9. So if the x plus 9 factor cancels out, that means that our whole is that x is equal to negative 9. We make that removable factor equal to 0 and solve. The vertical asymptote is the remaining denominator set to 0. So that's going to be x is equal to 9. Now it's pretty cool though that the x-intercept, what's going to make the remaining factor in the numerator equal to 0? Nothing. So there actually is no x-intercept here. And one of the reasons is because looking at our rules, we actually get a horizontal asymptote at y is equal to 0. And that's because the degree in the denominator is larger than the numerator. So if you think about an x and y plot, this is the x-axis. This is also y equals 0. So if I have a horizontal asymptote here at y is equal to 0, I can't cross the x-axis. So I'm not going to have an x-intercept. Now the y-intercept is where x is 0. So if I just make x 0, ignore this, I get negative 1/9. So I'll keep this blue. So my y-intercept is just going to be x is 0, y is negative 1/9. And that's it there. And that's it. I think there's one matching picture, but you can go through that. You're looking for asymptotes again, matching. But know this, know how to find your intercepts, find holes, all this, and really know how to factor and use vertex form. So this Unit B was all about quadratics and higher order polynomials. So make sure you're comfortable with all this and feel free to ask any questions.